Hey guys, I just wanted to make a quick video to kind of go over a few of the things that we didn't get to cover all the way in class. This lesson especially is a really good one to review for the checkpoint on Monday or Tuesday, depending on whether you're A or B group. A couple of things that I want to highlight for you. If you think back to section number 5 that we started with, it was all about how many x-intercepts there are and using those factors to figure that out, and then also thinking about how the number of factors determines what your degree is and how your degree determines what shape your graph is. So if you were to graph something in y equals mx plus b, this is a first degree polynomial. So anything that is a first degree polynomial is going to be a linear graph, whether it goes up positive or whether it goes down negative. This is a first degree polynomial. This is what a first degree polynomial looks like. A second degree polynomial, okay, will have something, so this would be x to the first power. A second degree polynomial would have x to the second power, and x to the first would be the biggest exponent, x to the second would be the biggest exponent here. And whether it opens up or whether it opens down, it's going to be a U-shaped. So a third degree polynomial would be an x cubed for your highest exponent, so x cubed, and it would look something like this. And a fourth degree would be something with x to the fourth in it, and that would look like a W or a flattened out parabola, something like this. X to the fifth degree would be similar to the third, but it would just have more bumps in it, right? So x to the fifth, so something like this. So the biggest thing that your checkpoint is going to hinge on is being able to factor. So when you factor, the very first thing that you always look for is GCF. So sometimes your GCF might just be a number, sometimes your GCF might just be a letter, and sometimes it might be a number and a letter. But always, the very first thing that you should be looking for is whether or not you have a GCF to factor out. And then basically that GCF, you're going to divide each one of your remaining terms by that GCF. So like, for example, if we look at 3x and 6, the GCF of 3x and 6 would be 3. So the GCF goes on the outside, and then we're just going to divide both of these by that GCF to figure out what's going to go inside the parentheses. So we have x plus 2, that's going to go inside the parentheses. So if we look at 12 and negative 6a, those are both factorable by 6. So if we divide this by 6 and divide this by 6, 12 divided by 6 is 2, negative 6a divided by 6 is negative a. On the last one, it has a 4x squared here and a 4x here, so the GCF would be 4x. And we're going to divide both of these by 4x. So 4x squared, 4 divided by 4 is 1. X squared divided by x is just x. So we would have x minus 4x divided by 4x. Anytime that you divide something by itself, it's always 1. Okay? Because the degree of all of the variables in here is degree 1, meaning that the highest exponent is 1, I know that I can't factor these down any farther. So these would be the final solutions for each one of these. Okay, so I'm going to leave that GCF up there because we're going to add on to that on the next slide when we continue to factor. So we're going to continue to factor now. If you look at this one, you have an x squared, a 4x, and a 3. Well, the numbers are 1, 4, and 3. The biggest factor is 1, and we never count that as part of our GCF, and not all of them have x's. So the way to do this one is the exponent, the degree, will tell us how many factors we need. And we're trying to get our factors in here to multiply to get us this. So we know that x times x is going to give us x squared, and what we're looking for these numbers back here are factors of 3. And those factors of 3 also then have to add up to a positive 4. So the only factors of 3 are 1 and 3, and the only way to multiply to get a positive and add to get a positive is to have 2 positives in here. So if you were to do the distributive property again, then you can see that x times x is x squared, x times 3 is 3x, 1 times x is 1x, and 1 times 3 is 3. So 3x plus 1x is where that 4x is coming from. Okay, so if there's no GCF, you're going to have to factor the remaining polynomial. Okay, so if the degree left inside after you factor out the GCF is 2 or higher, you need to continue to factor. So here, again, we're going to look for a GCF. So there's no number that's a GCF because the biggest number that they are all, that they have a common factor of is 1. And not all 3 terms have an x. So we look at the degree to figure out how many factors we need to set up. And we have x squared minus 5x plus 6. So we know that x times x is x squared. And now we need factors of positive 6 that also add to negative 5. So if the last number is positive, we know that we're either going to need 2 positives or 2 negatives. And I know that I'm going to need 2 negatives because the only way to get them to add to a negative is if they're both negatives. So factors of 6 that also add to negative 5. So 6 and 1 would not work because negative 6 and negative 1 is negative 7, but 2 and 3 would work. For f, the very first thing we need to do, again, look for GCF. So these are all divisible by 2, but that's our only GCF because these 2 have x's, but this one does not. So I'm going to start with the 2 out front, and then we're going to divide each of these terms by 2 to figure out what needs to go inside the parentheses. So 2x squared divided by 2 is just x squared. 6x divided by 2 is 3x, and 6 divided by 2 is positive 3. Now because there is a degree 2 polynomial inside that, we need to check to see if this part that's in the parentheses can be factored. So if we kind of ignore this part right now, we would need to set up 2 sets of factors and just check what factors of 3, and there's only 2 because 3 is a prime number, would also add to give us a positive 3. So 3 times 1 is 3, but is 3 plus 1 3? No. So in this case, that is the factored form of that polynomial. All right, next factoring page, last factoring page. So again, we need to look for a GCF. So we have a 1 for the number, which doesn't really count. We have an x squared, an x, and no x's. So that just means that we're going to set up our 2 sets of parentheses. I know that I need an x here and an x here. And now I need 2 factors of negative 6 that also add to negative 5. So the only way that I can get a negative when I'm multiplying is by having 1 positive and 1 negative. And so now I need multiples of 6, or factors of 6 that add to negative 5. So that would be a negative 6 and a positive 1. For h, again, we're going to look for a GCF first. So divisible by 3, divisible by 3, divisible by 3. So the GCF is 3. So we're going to divide everything up here by 3. So we have x squared plus 4x minus 12. And then now that this is a degree 2 in here, we also need to figure out whether or not we can factor this one. So the GCF is going to stay out front. We're going to set up our 2 sets of parentheses back here. I know that x times x is x squared, and I'm looking for factors of negative 12 that also add to positive 4. So I know that if I'm multiplying to get a negative, one has to be positive and one has to be negative. And when I add those two or subtract them, I need to get a positive 4. So positive 6 and negative 2. All right, the last one, again, look for a GCF. You have 1, 5, and 24, so the largest number that they're all divisible by is 1, which doesn't count. We have an x squared and x and no x, so there's no GCF for this one. So we're going to set up our two sets of parentheses. X times x is x squared. I need two numbers that multiply to get us 24, negative 24, but that also add to give us negative 5. So this would be negative 8 and positive 3. GCF is going to be huge, 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 huge. All right, from here, we're going to go to answering these questions about each function. So if we are going to rewrite this in standard form, it just means that we have to distribute, but we're only going to do it 2 pieces at a time. So we're just going to take these 2 pieces for now and distribute those. So distribute, distribute. So x squared minus 3x. And then we're going to do the same thing with the 2. So 2 times x and 2 times negative 3. So 2 times x is positive 2x, and 2 times negative 3 is negative 6. So I can combine these two because they are like terms. So I'm going to do, ooh, that's really big. There we go. X squared minus x minus 6. Now what I need to do is I need to multiply it times this x plus 1. So we're going to distribute, 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 or you can distribute this way. It doesn't matter whether you do this one times this one or this one times this one. So basically when you take x squared times x, you get x cubed. X squared times 1 is just x squared. So now we're going to take the negative x times x is negative x squared, and negative x times 1 is negative x. And then for the last one, we have negative 6 times x is negative 6x, and negative 6 times 1 is negative 6. And I'm just stacking these so that the columns are like terms. So x cubed, the x squares cancel each other out because one is a positive 1 and the other is a negative 1. We have negative x minus 6x, which is negative 7x, and we have a negative 6 here. So, name the degree. So you can either tell what the degree is by looking at this term right here, or by looking to see how many x's are in this one up here. So the degree is 3. The leading coefficient, if you look in standard form, it's the number that's out front. And this one, in this case, when there's no coefficient, remember there's really a 1 in front of that. The constant term, now if you want to get it from up here, you just have to multiply all the constants together. So 2 times negative 3 is negative 6, times 1 is negative 6, or you can look here and you can see it's the one without a variable. The horizontal intercepts come from the factors, so you cannot get the horizontal intercepts unless you have the factors, and these are the factors up here. Remember, a factor is just something that you multiply together to get something else. So the horizontal intercepts are going to be these numbers here, and remember, all we're looking for is what value of x is going to make this factor equal to 0. So if I put a negative 2 in here, negative 2 plus 2 is 0. For this next one, what value of x is going to make just this factor equal to 0? So that would be a positive 3. And then for the last one, again, what value of x can we put in here so that just this factor is equal to 0? And that would be negative 1. The vertical intercept is going to be from this one right here. So that's negative 6. It's your constant term. And the shape of the graph is going to be like this because it's a third degree, so 1, 2, 3. So we're going to sketch a graph of this function, okay? We know that our horizontal intercepts are negative 2, positive 3, and negative 1. And we know that the vertical intercept is negative 6. So when we sketch a graph, when we sketch this graph, it doesn't need to be pretty, you guys. So it's going to...
Please excuse the interruption. So about the software...
It doesn't have to be pretty. So this is what it's going to look like. You're going to start down here. Something along these lines, okay? All right, for the next one, okay? This time it's in standard form. We are going to rewrite it in factored form. So remember, anytime that we're factoring, the very first thing we want to look at is GCF every single time. So if we look at the numbers first, you have a 1, a 5, and a 4. So we don't have any numbers, but if you look, you have an X, and an X. So that means our GCF is going to be X. So we're going to divide each one of these by X. So X cubed divided by X is X squared. X squared divided by X is X, and we still have to keep that 5 in front. And 4X divided by X is just 4. Now because the degree inside here is 2, we need to make sure that we continue to factor it. So I know X times X is X squared, and this part is just the GCF. This is just this dropping down. This part is going into these two parentheses right here, just like we did on the previous pages. So now we're looking for factors of 4 that also add to 5. So the only factors of 4 that add to 5 would be 1 and 4. Okay? So name the degree. The degree is either going to come from how many x's there are, or it's going to come from the biggest exponent. Either way, our degree is 3. And so that's going to tell us what the general shape is. So again, that general shape is going to look something like this. Okay, the leading coefficient, again, that's the number that is all the way out in front when it's in standard form. So that's 1 if there's no other number there. The constant term, so I'm going to rewrite this equation just a little bit, okay? Woo. Not what I wanted to do. Okay, I'm going to rewrite this as another factor. So x is the same thing as x plus 0 or x minus 0. So if you want to find the constant term, remember there are 2 ways to do it. You can multiply all of these numbers together, so 0 times anything is always 0. Okay? The other way that you can think about this is if you look up here, what term has no variable with it? Well, this one has a variable, this one has a variable, this one has a variable. There's no term without a variable. So what number represents nothing? That would be 0. So your constant term is 0. The horizontal intercepts come from factored form. Remember, that's when you're trying to figure out what value of x makes each one of these factors equal to 0. So our first horizontal intercept, if you just have an x here, that's the easy one. The horizontal intercept there is going to be 0, because if I put 0 in here, then x is equal to 0. That factor is equal to 0. So the second one, what value of x makes this factor 0? That would be -1. And the last one, what value of x would make this factor equal to 0? That would be -4. The vertical intercept, remember, is the same thing as the constant term. So if you found the constant term, you've also found the vertical intercept. So this vertical intercept and the horizontal intercept, those two overlap. Okay, they're the same thing. So then we also have -1 and we have -4. So when we sketch a graph, it's going to start down here, come this way, go like this. Okay? If you need to start with these, go ahead, start with those, right? If it's positive up here, it's going to start low. Okay? All right, next one. Okay, again, rewrite in factored form. So anytime that you have a difference of squares, difference because it's subtraction, squares because these are both perfect squares, all you're doing to factor it is you're taking the square root of each of these, so the square root of x squared is x, The square root of 16 is 4. And the only way that you can multiply to get a negative 16 is to have one positive and one negative. So there's factored form. Name the degree, again, that's either how many x's you have or the biggest exponent up here. So the degree would be 2. This is a second degree polynomial. The leading coefficient, again, is 1. The constant term is negative 16. Be sure that you take the sign that's in front of it. And you can also look over here. If you take these two constants and multiply those together, you would get negative 16. The horizontal intercepts, remember, those come from your factored form. So here's x plus 4. What value of x makes this factor 0? So you would have negative 4. And what value of x makes this factor equal to 0? That would be positive 4. The vertical intercept is the same thing as your constant. So this would be negative 16. That's not going to fit on our graph, but we'll be all right. And then what shape will the graph be? It's squared, so that means it's going to have a U shape. Okay? So we have one intercept at negative 4, one intercept at positive 4. Our y-intercept would be down here at like negative 16. Okay, so we're going to pretend like that's all the way down here. Negative 16, positive 4, negative 4. So our graph would look something like this, except it would go through that point there. Okay. Again, rewrite in factored form. We want to make sure that we check for GCF first. So we have 1, negative 2, and negative 3, so there's no numbers in our GCF. We have x squared, x, and no x, so we know that we can just start factoring. Okay, there's no GCF for this one. So I know x times x is x squared, and now I'm looking for factors of negative 3 that add to negative 2. So if I'm multiplying to get a negative, one is positive and one is negative. So the only factors of 3 are are 3 and 1. So negative 3 and positive 1. Degree, we have 2 x's, or we have this exponent here, which is 2. Leading coefficient, there's no number in front of the x squared, so we say that it's a 1. Constant term, you can either multiply all the constants here or look at this one, which would be negative 3. Horizontal intercepts, those come from the factored form. So what value of x makes this equal to 0? That would be negative 1. And what value of x here makes this factor equal to 0? So that would be a positive 3. Remember, the vertical intercept and the constant term are the same thing. So your vertical intercept would be negative 3. And the general shape, it's a second degree polynomial, so it's going to be a U shape. So y-intercept at negative 3, horizontal intercepts at negative 1 and positive 3. And a general shape for a general sketch of this graph would be something like this. Now, the intercept is not always going to be the relative minimum or the minimum of this graph. Your relative minimum would be halfway in between these 2 points right here. So your relative minimum would be somewhere down here. This is simply just the point where it crosses the x-axis. All right, so for the next one, this one is in factored form. So to rewrite this in standard form, this is going to be a really long one. So I'm just going to quick go through this one. Let's just do 2 at a time. So if we distribute this one, 3x times x is 3x squared. 3x times negative 1 is negative 3x. And then 2 times x is positive 2x. And when we combine those two, we're going to get a negative x. So I'm just going to leave that like that. And then 2 times negative 1 is negative 2. So now we're going to take this one and we're going to multiply it times this one here. So we're just going to take this and we're going to multiply it times that x minus 2. So x times 3x squared is 3x cubed. X times negative 1x is negative x squared. X times negative 2 is negative 2x. And now we're just going to distribute the 2 through. So negative 2 times 3x squared is negative 6x squared. and we're gonna combine that with this one, so that's negative 7x squared. So I'm just gonna kind of stick that in there. And then negative 2 times negative 1x is positive 2x, so that's gonna cancel this one out right here. Because positive 2x and negative 2x is 0, and then negative 2 times negative 2 is positive 4. And then we need to take that one times the last one here. So we're going to do x plus 4. So x times 3x cubed is 3x to the 4th. X times 7x squared is negative 7x cubed. X times 4 is positive 4x. And then we distribute the 4 through. So 4 times 3x cubed is 12x cubed. So when we combine that with this one, that's going to give us a positive 5. Positive 4 times negative 7x squared is negative 28x squared. So I'm going to fit that in here. Negative 28x squared. And then 4 times positive 4 is positive 16. So I'm just going to move this 4x over. 4 times 4 is 16. And then I'm going to move this minus 28x squared down. Minus 28x squared down. So this is the polynomial for this in standard form. So again, name the degree. You can either count that from how many x's are in the factored form, so 1, 2, 3, 4, or you can look at the degree, the exponent here. So the degree is 4. The leading coefficient, again, if you want to multiply all of the x values here together, that would give you what your leading coefficient is, or you can look at standard form and it's right here. The constant term, if you want to do it from factored form, you can multiply all of the constants together. So 2 times negative 1 times negative 2 times 4, or you can look at this one right here, which would be positive 16. The horizontal intercepts, you get those from the factored form. So this one here is going to be a little bit tricky. So we're going to do this one last. We're going to do these 3 first. So the horizontal intercepts. What value of x is going to make this whole thing equal to 0? That would be a positive 1. What value of x is going to make this whole thing equal to 0? That would be positive 2. What value of x is going to make this whole factor equal to 0? Negative 4. Okay? Really what you're doing is you're taking every factor and you're making it equal to 0. So if I were to solve this equation, I would subtract 2 from both sides and solve that equation. So my other one would be negative 2/3. What is the vertical intercept? Remember, that's your constant term, so that would be positive 16, and then sketch a graph of the function. So again, where are our x-intercepts? We have one at negative 2/3, one at negative 4, one at positive 1, and one at positive 2. So our graph is going to look something like this. Oh, we need the vertical intercept too. The vertical intercept is at 16, so that's like way up here off the paper. We'll pretend like it's all the way at the very top. So if we do that, then our graph is going to look something. Whoops, sorry, that's not right. Oh, good grief. Here we go. Like that. Okay, it's got to be a W shape if it is a 4th power. Okay, these last ones, okay, are just writing the equation. So if you want to write a polynomial for a function with the following properties, it has x-intercepts at negative 3, 0, and 5. Remember, x-intercepts come from the factored form. So if you do f of x is equal to, you're going to have 3 factors because you have 3 intercepts. So they have to be the opposite because this is the value that makes this factor equal to 0. So you would have x plus 3. You would have x either plus 0, minus 0, or just the x by itself. And then for the 5, x minus 5. And you can tell that you have it right because it's going through all those points on the x-axis. If it went through, sorry, x plus 5. So you can see, like, if I put a plus 5 here, it's not going through this point, it's going through negative 5 over here. So this one needs to be minus 5. Okay, for the next one, we need a second degree function, which means that it's going to have to be something squared. Okay, so f of x is equal to, x squared, but it needs to cross the vertical axis at -4. So I can put the -4 here. Now I can change this equation as much as I want. I can put a coefficient on that. I can make that a negative. I can make it a fraction. I can even put in another term here. So I could do plus 3x. As long as this constant stays at -4, this y-intercept is still going to be -4. Okay, so again, we need a 4th degree polynomial. So 4th degree just means x to the 4th, or it has to have 4 terms. Okay. We know that the x-intercepts at -2 and 6 would be x plus 2. See how that's going through -2. And x minus 6. See how that's going. Now, what we needed to do is we needed to reflect off the x-axis at 3. So when it says to reflect off the x-axis, you can see we've only got 2 x's here, but it's supposed to be a 4th degree polynomial. So I need 2 more x's. When it says that reflects off the x-axis at 3, we need this to be -3, but we need it to be that quantity squared. Whoops. Like this. So now it's reflecting off the x-axis. It's not crossing it. As soon as it hits it, it bounces off of 3. Okay, so that's what this squared outside here does, is it reflects it across this x-axis. If you guys have questions, please make sure that you don't wait until Monday or Tuesday to ask your questions. Please send me a remind text. Please email me. Get a hold of me somehow so that if you have questions, you can get them answered before you take the checkpoint.